Hi friends, in this video we will learn how to configure site-to-site VPN with stateful failover. Okay, please understand the IP addressing and topology correctly before configuration. Okay, you can assume we have a head office. Okay, in head office we have two routers R1 and R2. They are connected with ISP. We also have a remote location, that is R3, that is also connected with ISP. Okay, so here you can see this branch router will initiate session with the virtual IP. Yes, virtual IP, here you can see 101.1.100. Okay, first R1 is primary, R2 is secondary. Okay, first of all, for virtual IP, R1 will be active and it will responsible for VPN connections. Okay, when R1 link will goes down, then secondary will become active, then it will be responsible for virtual IP. So here there is no need to reestablish the connection. The peer will only initiate a session with the virtual IP. Here R1 will become first, R1 is primary, R2 is secondary. If R1 will goes down, yes, R2 will become the active. So this is our stateful failover. Okay, in stateful failover, if failover occur, there is no need to reestablish the connection, because here you can see virtual IP is here same. Okay, so this is our topology. Let's start the configuration. We will start configuration from PC1. Okay, PC1 IP is here, and its gateway. Verify the IP addressing and route. Yes, we have configured. Then we have to configure R1 lane, R1 WAN, we will also define default route toward the internet. Verify the IP addressing and default gateway. Then we will configure R2 IP lane, R2 WAN, then we will also define default route toward the internet. Verify the IP addressing okay, then we will configure the ISP. Okay, verify the IP addressing. Then we will configure to R3 WAN IP, lane IP, then we will define default route for internet. Verify the IP addressing and default route. Then we will configure PC2 with default gateway. Okay, then its gateway is 102.1. Verify the IP addressing. Yes, we have configured the IP addressing properly. Now we have to use here HSRP. Go to R1. We will go to lane. Standby 1. Virtual IP will be here. 101.1. Here we want it should be active, so we will increase the priority. Okay, if it has higher priority, take over the role, then we have to enable preempt. Okay, it will be active if f0 by 1 is up. Here we are saying you will provide services for the virtual IP 101.1. You will be most active, then your priority default priority 100. So here we will increase the priority 101. Preemption commands force a router to take over the role if it has higher priority. Now here we are saying you will be active until your exit interface is up. Okay, then same, we will go to 0 by 1, standby 1, virtual IP. Here we are using virtual IP 100. Okay, then we will use here priority, yes. We will also use here preemption, and then we will say you will be active if your lane interface is up. Here we will also give a name to this HSRP group. Here we can see anyone you can choose here. I'm using here Shiva. Then what we will do, exit. Then we have to use a command redundancy inter device. Okay, scheme standby. And what is the name of HSRP group here? Yes, you have to define here. Then you have to use a protocol IPC inter process communication IPC zone default association 1 protocol stream control transmission protocol local IP address. Yes, here we will use this protocol. Okay, local IP address here you can see 101.1.10. okay, sorry, we have to use define here local port number, then local IP address. Yes, local IP address will be this one. Then we will exit. Then we will use okay remote port will be 5000 for remote IP address 101.1.20. then exit, 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 do history. Okay, so what you have to do, you have to use this command redundancy. Yes, we want to set redundancy between inter devices. Here what we can do, we can take it to the notepad, paste. If you are not able to see, then what we can do, we can increase the font. Yes, here you can see. Okay, so good. Okay, so here you can see we are saying that we will set okay, what is the requirement of this protocol? Look here, this R3 will initiate session with this virtual IP, and who is active for this virtual IP? Yes, R1. So all attribute will be exchanged with R1. Okay, what will happen when R1 will goes down, then R2 will become active for virtual IP, but it doesn't know to whom primary has established session. For that we have to use here protocol, this one IPC inter process communication. Okay, so here we have to set okay, you will use your local IP 101.1.1.10 local port 5000. You will communicate with this IP port number 5000. So here we have to do same reverse configuration. Local port will be 20 and local IP will be 20 and remote IP will be 10. Okay, but before it we have to configure at R2 HSRP setting interface F0 by 0 standby 1 IP. Yes, virtual IP is here 101.1, and then we will enable here preemption. Then we will go to 0 by 1 standby 1 virtual IP 100. Then we will enable here yes preemption, and we will also define the same name which we have defined there. Yes, Shiva. Then what we will do, yes, we will copy these command and we will paste them. Okay, so when you will do this configuration, what you have to do, write and write. Okay, show redundancy inter devices. It is saying pending scheme will not take effect until next reload. So what we have to do, we have to reload both devices here. So how we can reload? Just simply right click, reload, right click, reload. Yes, Now, but remember it, before reloading you have to write the configuration, otherwise all the configuration will be flush. Okay, done. Then we have to do what we have to configure here, site to site VPN. Okay, crypto ISCAM policy 1, authentication pre-shared, encryption AES, hashing SHA, Diffie-Hellman group 5, lifetime 1800, crypto ISCAM key, yes, Shiva, address, yes, peer address is here, yes, our peer address is 102.1.1.100. Crypto IPsec transform set, you can use any name, ESP, AES, ESP, SHA, HMAC, mod, tunnel. Crypto IPsec Security Association lifetime second. Access list 101, permit IP when source is my lane, yes, and destination is remote branch lane. Crypto map test 10 IPsec ISCAM set transform set, yes, T set peer 102, match address 101, and we will apply it at exit interface crypto map test. Okay, but along with this what we have to configure, redundancy name of the HSRP group Shiva, and which type of failover you want to enable, yes, stateful. Okay, no problem, do show history. Okay, now same configuration what we have to do, we have to do on R2. Crypto ISCAM policy 1, authentication pre-shared, encryption AES, hashing SHA, Diffie-Hellman group 5, lifetime. Then crypto ISCAM key Shiva, address 102.1.100. Crypto IPsec transform set, T set, ESP, AES, ESP, SHA, HMAC, mod, tunnel. Crypto IPsec security association lifetime second. Access list 102, permit. Okay, you can use here same, permit IP when source is my lane, yes, what is its lane, 101.0, and destination is here 102. Then crypto map test 10 IPsec ISCAM set transform set, T set peer H address, yes, which access list we have defined here, 101. Then we will apply it at exit interface crypto map test redundancy Shiva stateful, HSRP group name which we have defined here, do show history. Yes, then where we have to go, yes, we have to go to on. Okay, remember it, the configuration should be here same. Okay, then we have to configure R3. Okay, we will configure now R3. Crypto ISCAM policy 1, authentication, encryption, hash, group, lifetime. Then crypto ISCAM key, yes, Shiva, with the address. Okay, it will establish session with virtual IP, and here virtual IP address is 101.100. Crypto IPsec transform set, T set, ESP, AES, ESP, SHA, HMAC, mod, tunnel. Crypto IPsec security association lifetime second. Access list, you can use here any number. Permit IP when source is my lane, yes, its lane is 102, and when destination is 101. Then crypto map test 10 IPsec ISCAM set transform set, T set, set peer, and match address. We will apply it at exit interface. Exit interface is fast Ethernet 0x0. Crypto map test, do show history. Okay, same authentication, encryption, hash growth, lifetime key, transform set, security accession, access list, crypto map, in crypto map set, transform set peer match address, and we will apply it at exit interface. Now you have to go to PC2 and ping 192.168.101.100 to PC1. Repeat count. Okay, wait. Okay, it's working. Okay, now go to R1. Show crypto IceCamp SA. Yes, there is session with 102. Show crypto IPsec SA. Yes, how many packets encrypted, decrypted? And show crypto engine connection active. Same you have to go to. Okay, now you can see here we have established session with R1, but here we are using IPC interprocess communication or communicator. Then you can see here show crypto IceCamp SA. Yes, this is for standby state. Here you can see active. Then show crypto IPsec SA. Okay, the no packets encrypted here, that's why it is showing the null. Okay, and you can see all attributes are exchanged here between primary to secondary. Now what we have to check? Okay, we will down the primary, and who is primary router here? Yes, R1. Okay, we will down interface F0 by 1. Then what? Shutdown. When we will disable shutdown it, then it will active for virtual IP 101.1.1.100, as well as now another gateway, the lane gateway is also now active. Now check. Yes, you can see communication is going on, and it will start encapsulation and decapsulation. Show crypto IPsec SA. Yes, so here you can see our peer. First it will establish session with virtual IP. First R1 will active. If R1 will goes down, secondary will become active. Okay, so this was our IPsec site to site VPN with stateful failover. Thank you.